Our presenter today is Chris Ross. Chris is a senior technical support engineer on the McAfee data protection team. He's been working in technical support at McAfee for over 8 years, specializing in the McAfee encryption products. Previously, Chris has supported SIM, McAfee HIPS, and ePolicy Orchestrator. Ladies and gentlemen, here's Chris.
Hello, everybody. Welcome. Today we are covering the subject of McAfee Drive Encryption disaster recovery scenarios. Our agenda today will start with a brief disclaimer as the situation requires. We will discuss the DETech tools, creating the recovery media, various authentication methods, some of the functionalities of the recovery tools like the emergency boot, viewing disk information, removing DE, the force crypt or force crypt sectors or force decrypt as it's known. We'll discuss the WinPE options, when to use either or, and options for the creation. We'll also discuss the EPO disaster recovery considerations with regard to the drive encryption components, and then we'll have a Q&A. The disclaimer, this webinar is a brief overview covering some of the most common use cases and scenarios regarding drive encryption system recovery. It's not possible to cover all the recovery scenarios, especially in the hour webinar. If any assistance is needed with any of these aspects with MDE system recovery, please contact us. McAfee Technical Support will be glad to help. Starting off, before we even get into the DETech subject, with McAfee Drive Encryption, if we have issues at pre-boot, for example, username is not recognized or users entering a password and it's not being accepted, we have basic recovery options before we ever get to using any kind of recovery disk. That'd be the administrative recovery options. This has to be enabled in the policy prior to the scenario coming up. If it was not enabled beforehand, the recovery option here won't be available. This is enabled by default and is generally recommended to be left as such. On the client system, if you're in a scenario where the user's entered their username and it's given an unknown user error message, or they've entered their username and then typed in their password to authenticate and have not been successful, they've been met with an error, then they can choose the recovery option highlighted here. When selecting that recovery option, it will then bring the system's user to this next screen on the right, offering either the administrator or smartphone recovery or a question and answer recovery. Upon choosing the administrator recovery, they will be given the client code that's listed here and also phonetically spelled out. Of course, that client code will vary from system to system. It is unique. They'll contact the EPO administrators or help desk as applicable, requesting the recovery, and then when the administrator that's providing recovery services is ready, they will go to this page under Menu, Data Protection, Encryption Recovery in the EPO console and wait to have the code read to them. Once the code is input, then the administrator will be given a series of options. The first option, Machine Recovery, will provide just a single boot past the pre-boot authentication screen. The next section below is the user recovery options, in which they can choose to unlock a disabled user. That would be in a scenario where a user was disabled in Active Directory, and upon syncing, we subsequently disabled them for McAfee Drive Encryption. The next option below that is to reset token, which will allow the user to change their password. The final option, reset to password token, has the same net effect as a reset token, but is used in scenarios where the user does not typically use a password token. For example, if they're using a common access card or a PIV card. Once the option is chosen and the administrator selects next, they'll be presented with the response code listed and phonetically spelled out that they can read back to the user. The user on their local system will input the code as read out to them. There's usually, for the different recovery key sizes, the minimum size, which was shown earlier as low, will be a line and then a second partial line. Once both components have been entered, they'll be able to finish, or hit enter and then hit finish, and it will carry out whichever action was applicable. That would be either booting the machine once or allowing them the option to set their password. There are also self-recovery options, which remove the need for the user to contact the help desk or an EPO administrator. They can use some preset security questions whenever they initially set their password. If this option is configured in the policy, they will be asked to set their questions. There are some preset instances that already exist in the policy, or you can choose to set up your own. If you set up your own in the policy, those will be what's presented to the user. They'll have to choose their questions, set their answers, and then we'll be able to use these in a recovery scenario to change their password if they don't remember it. The QR code with the Endpoint Assistant app is another option that allows an equivalent to that administrator recovery, but without requiring the administrator. It's available for iOS phones and Android phones in the App Store, Google Play Store. The frequently asked questions KB article for the Endpoint Assist app is in KB 80070. Whenever you're using this option, it will require that companion device is allowed in both the user-based policy and the product settings policy for drive encryption. Under the user-based policy, you also have the ability to govern the authentication that takes place on the Endpoint Assistant app. You'll see the default here is showing the PIN at exactly 6 digits. You can expand upon that and even go to a password configuration. This would need to be preset. If the user is encountering an issue and have not enabled these options, then they won't be available. So you'll want to have this enabled ahead of time if you plan to use it. If so, then the user will need to download the Endpoint Assistant app. Whenever they download it, this is the primary screen. They will need to set a 4-digit code by default after downloading it, but whenever they register it, it will adhere to the policy as configured. So at the initial pre-boot after authentication, it will have them scan the QR code. Once the code is successfully scanned, then it will adhere to the policy as noted here. It'll indicate the administrator has set a more stringent requirement and they'll have to update it. After the code has been scanned and the authentication has been set, it will then be registered and be available to use for the recovery. So looking at the previous screen before where we only had the client code, you'll notice now there's a QR code there. They can still use the client code option with an administrator, or they can use their phone to scan that QR code, and then their phone and the app will provide the response code instead. Going on to the DETech recovery tool now. This is actually situations where we're going to need a recovery media to address the situation. We've got a whole family of these tools available for these disaster recovery scenarios. Some of the reasons for using DETech will include an issue or problem with the drive encryption pre-boot file system has been altered, damaged, or corrupted. Sometimes that can be from third-party software or another instance of software moving or altering files in the pre-boot file system. Rootkit infection of the master boot record on a legacy BIOS system can also cause problems loading the pre-boot file system, as well as on UEFI systems, files within the EFI partition being altered or removed. We have noted several variations of the DETech options. We have DETech options within the Windows PE environment. This is then our application and appropriate plugins and drivers to allow use of DETech within the Windows PE environment. It's available for standard regular encryption, the DETech. It's also available for DE OPAL-Tech. I'll take a moment to note the standard DETech is referring to a drive that is used the basic PC software encryption from McAfee Drive Encryption that is sector by sector encryption. The OPAL provider is another option that Drive Encryption offers, in which instead of encrypting at a sector level on supported OPAL hard drives, we actually activate or lock and unlock the OPAL drive. In this instance, we are not actually, the drive encryption software is not actually encrypting or decrypting, but rather interacting with the OPAL firmware and using that to lock or unlock the drive. The standard DETech and the DE OPAL-Tech can be used in UEFI environments. We also have the option for DETech Standalone. This, rather than being an application in Windows PE environment, is going to be a standalone application or environment that can be used in legacy BIOS, either standard or DETech or DE Opal-Tech. The DETech software for Opal encryption does not have a standalone for UEFI. That will be in a Windows PE environment. The listings of what DETech can do, the features listed over on the left, vary depending upon the type of environment you've chosen to use. For anything in which the PC software provider was utilized, the sector by sector encryption, it's going to be one of the DETech, either standalone or in WinPE. And then if you utilized the Opal provider, then it would of course be the DE Opal-Tech instances, either in WinPE or standalone as applicable. One of the most common features listed there at the top, the emergency boot, is only available in the standalone media options. It does not exist in the WinPE variations. The WinPE, however, offer the option of actually recovering data from the drive while still encrypted. The option to remove DE exists in all of the instances. The option to remove DE decrypts or deactivates and reverts the boot process, but does not remove any software. This is operating just to remove the encryption and change the boot process back to a Windows boot process. The option to crypt sectors and force crypt sectors does not apply to the Opal variations because we are not encrypting the Opal variations, we are locking and unlocking. Whereas in the standalone DETech and the WinPE DETech, using regular encryption, we do have the ability to encrypt, decrypt sectors. The option to repair disk information, this relates to drive encryption disk information, only exists in the DETech standalone, and all of the instances have the ability to view disk information. The creation of the tool varies a bit depending upon which tool is going to be used. We have a sample video showing the build process of the legacy BIOS DETech standalone. All of these will start out with the DETech or EETech downloaded folder that you can get from the EPO Software Manager software catalog and also from the download site. Process will start off, of course, extracting that EETech zip. Once downloaded, for this instance, we're looking in the standalone folder. You'll notice there's a few different variations of files as well as an executable. For the legacy instance, we will be formatting. There is a command noted, and this is all this information is in the DETech guide. We'll follow the format command listed in that DETech guide to format our USB device that we're going to utilize as the recovery media. The process can take just a little bit of time. It varies, of course, in the format depending upon the size of the USB device. We typically try to recommend the use of a smaller USB device if possible when using the DETech standalone. It's a very small utility. It doesn't require much space. You will want to include enough space, though, to allow for the presence of the recovery XML file if necessary. And upon completion of the format, we then will utilize the bootdisk.exe application. We'll want to navigate to that location in the command prompt. Once we're there, we'll utilize bootdisk.exe. The syntax is the command name, then the name of the file, either EETech or EEOpalTech.rtb, and then you'll point to your drive letter of your USB device. We want to be careful, make sure we do have the correct letter selected. This will give a warning that indicates that it's about to write to it, and gives you the option to abort. you want to make sure that you are writing to the correct device. Once that's done, your USB device will now be a functional DETech recovery media. It'll have these two files, the boot sector and the actual application or environment. Looking at a next video option, this is going to be the same tool type, the DETech Standalone, but in a UEFI environment. Again, we'll start off with extracting the zip file. Once extracted, again, we'll venture into the standalone folder. Now, rather than using the RTB files in the application, we're going to be looking at one of the two EFI files. This will depend on either being a 32-bit or 64-bit EFI application. We'll complete the format process just as before. Again, the command is in the DETech guide. And once our format's complete, we'll actually navigate in Windows Explorer to the USB device, and we're going to create a standard EFI boot structure. This will be the folder at the root called EFI, and within there, a folder called boot. Once that structure is created, we'll go into the EFI boot folder, and we will place whichever of the two EFI files we need, either 32 or 64-bit. In this case, we're going to take the 64-bit instance. Once that is copied and placed in that location, we will then need to rename it to either boot x64 in this case for a 64-bit environment, or boot IA32 for a 32-bit environment. Both will need to leave the .EFI extension. And at this point, you now have a standalone DETech bootable USB device for an EFI environment. Once we have our media, whichever of the two we needed to create, either standalone for EFI or standalone for legacy, this also applies to the PE environments that we'll get to a bit later. Whenever you get in, there are limited options available. You'll have to authenticate before you're able to carry out any of the actions. Token authentication is the first option available that's listed in the corner in the section for authentication. This utilizes the credentials of a drive encryption user from the pre-boot file system. It's usually the quickest and easiest way to authenticate. The authentication is the same process as if you were authenticating to the pre-boot environment normally. However, this may not work in many recovery cases because the pre-boot file system may not be in proper shape. In cases where you're not able to use token authentication, the file authentication becomes the option you have to use. It uses recovery data that's stored in EPO. It does require that the DETech application access the recovery XML file and load it to be able to authenticate. Both the token and the file authentication do provide access to the same features and functionalities within the DETech environment. Once we are authenticated, we have several options for recovery. Which one we're going to choose will vary depending upon what the situation is with the system, what the problem is. If we have a drive encryption pre-boot environment that is not loading properly, providing an error rather than loading to pre-boot, typically the emergency boot is going to be the option. If you see an error indicating EEPC has been corrupted, for example, that's normally going to be a situation where we would want to complete an emergency boot. This does two main things whenever you complete an emergency boot. It bypasses that faulty or corrupted pre-boot file system, and also, once in Windows, places the system into a recovery mode, which allows the pre-boot file system to be rebuilt. As noted before, the WinPE environments do not have the emergency boot functionality. This only exists in the standalone instances, and it can also not be used to fix any Windows boot issues. So if you have a system, for example, that boots properly to drive encryption pre-boot, and then after authentication you end up with a Windows bug check or blue screen, it's not going to be able to correct that. After emergency booting, it will try to load into the operating system, and if the operating system's having issues, it will still see those same issues. The disk information section is utilized on both the standalone and the WinPE options to get a layout or a picture, if you will, of the disk and its current state. It contains critical drive encryption information, identifying which drives or ranges are encrypted. It includes information on the partitions of the drive itself, and also contains the disk key check value. That key check value can be very, very important in instances where systems are not able to be found in the EPO server. For example, if a system was deleted, the key check value is our option to use to obtain the recovery file. Whenever you take this key check value, it's highlighted over on the right. You can go into the EPO server, and in the system tree, without selecting a system, you can go down to the bottom and go to the actions menu, and under drive encryption, without a system selected, most options are unavailable or grayed out, but there is an option to export the recovery information based on the disk key check. So if the system wasn't there, you could still go here and input that key check value. It then, after you enter it and hit OK, will provide you the recovery XML, just as if you had exported it directly from the system entry in EPO were it there. Now, back in the DETech environment, we had talked about the emergency boot. If that option is not viable, either because the emergency boot's not able to complete for any reason, or if the issues existed beyond the drive encryption pre-boot file system, for example, the scenario mentioned a minute ago where the pre-boot was functional, but there was an issue in the operating system, you can use the option to remove DE to decrypt the encrypted ranges on the drive, and then revert the pre-boot file system or the boot process back to a Windows process. It decrypts and removes everything based on the presence of the crypt list and updates it. So if it's in progress, as it progresses, it's updating the crypt list with the current state. Below, you'll notice the option for force crypt sectors. This is useful in instances where remove DE is unsuccessful, a situation where you've chosen to decrypt and deactivate for your recovery purposes, but let's say the disk information is not available. If the disk information is not available due to a corrupt pre-boot file system, then we would provide the information in a force decrypt scenario that does not require the presence of a crypt list. You provide the start sector and the sector count. It does not rely upon the presence of a crypt list, and of course does not update a crypt list. Upon completion, you will need to restore the MBR, the original Windows MBR, if it's in legacy BIOS mode. When we talk about the force crypt sectors or force decrypt, this should be noted as the final or last option to use in DETech. We're going to recommend the attempt of remove DE first. That's usually the best way to go, since it does actively use the crypt list and update it. So in the event of a stop or failure, the progress should still be noted, whereas the force crypt sectors has no monitoring. The force decrypt is recommended, or prior to force decrypt, it's recommended to perform a sector by sector clone of the drive with no compression. This is the best option to ensure that your data is not lost in the event of a failure during the forced decryption. It provides a clone of the drive that can either be used for the forced decryption itself or can be referred back to or utilized if the initial one fails. If the sector by sector backup isn't created and the forced decryption is unsuccessful, for example, a power loss unexpectedly, an instance where a system has a hard drive failure at that point, permanent data loss is possible. When we talk about cloning sectors, this does need to be cloned to an identical drive, identical make, model, and sector count. In discussing the option below, or the mention below, of ensuring that sectors can be decrypted in the workspace, once you have completed the clone, we do have a workspace option in the DETech. This workspace allows you to load and view sector by sector to confirm the presence of what is there and the crypt state. When completing a forced decryption, this option, different from the remove DE, also, since it doesn't utilize a crypt list, has to be done one partition at a time. And the best practices for forced decryption are referenced in KB Article 66433. The forced decryption option is demonstrated here in a short video. We'll start off with the authorization. This is the code of the day. You can get this from the DETech, Drive Encryption Code of the Day tool. It varies day to day. Then in this case, we're going to go ahead and use the token authentication, just for simplicity of demo, although many times you would have to go with file authentication instead. We go to the disk information and locate what we need to know about the encrypted ranges. If your crypt list is not populated, you still have the option to complete a force decrypt. You would just utilize the partition information listed below, and you would check that in your workspace. In the workspace, we're going to confirm the information we had in our crypt list. We'll load a sector from the disk. That start sector of this range is going to be listed here, and we'll just load a single sector in for check and confirmation purposes. Looking at this as loaded, the data is obfuscated, and after pressing Decrypt Workspace, you can see now in the upper and lower right, we have areas that are legible. It's a bit broken up by the format of the hex editor, but it's obviously more legible than the encrypted information. With that information confirmed, we will then use the force crypt sectors option. It does give you a warning that is in keeping with our recommendation to clone. After selecting OK there, we will enter that full range that we wish to decrypt. So given the start sector and that number of sectors that was pulled from the disk information, I do highly recommend that the information be double checked. A lot of times, if you're on the phone with us in support, we will ask to read out those numbers. We'll document them and read them back. You can also use a mobile phone or other camera to take a picture. And of course, you can use Notepad as well, just to confirm that you have the correct numbers. It's also recommendable prior to starting the decrypt action to snap a quick picture as well, just in case there's any doubt or question about what actions were carried out in the recovery process. Going into the WinPE environment, just as the standalones have instructions, the DETech user guide has steps to build the WinPE environments as well. There is actually a separate KB article that lists the options to create a WinPE image with provided scripts. The guide has a step-by-step process. Then there's a set of scripts, and then there's also the EZPE option, which is a free option. It's easy. The tool can be found at the link listed here. Wait for a moment if you want to make note of it. And then KB 79853 also discusses the EPE Win Upgrade tool. This tool has multiple uses, one of which is the ability to inject the MDE components using this tool in command line into a Windows PE WIM image. The script that I'd mentioned before is now included in the DETech zip package, making the build process of WinPE easier. It is essentially the same process as what's documented in the guide, but just put into a scripted form, simplifying the process. It can be used to build either a WinPE with DETech or with DE Opaltech. Building the WinPE, regardless of method, will require the presence of the Windows Assessments and Deployment Kit version 4 or later. We'll also extract the WinPE folder from that DETech as before, and then we will create a copy of the PE environment to be used for the build. Example process or demonstration of utilizing the script shown here. As before we get the DETech folder extracted. I should also note while this is extracting, you hear DETech and DETech. This just comes from the difference in name of the product as time has progressed. DETech and ETech are interchangeable terms. That WinPE _tech CMD is the script that's utilized to build. In this case, the system already has the ADK software from Windows. We'll launch the DNI set environment.bat, which gives you a command prompt set in the proper location. At this point, we'll run our copy PE command. This creates a copy of the existing PE environments that come with the ADK, allowing you to leave the default ones in place and modify a separate one. In this case, we're going to be going with a 64-bit WinPE environment. This command is being used just the same as what's listed in the guide, with the exception of the location. This example location is slightly different. If you use a different location, your subsequent commands will also have to be adjusted to reflect that different location. Now that the environment is copied, we'll go ahead and go into the location where our script is, and we will run the script. There's a command syntax here where you name the script, you give the location of the PE environment that you're to inject to, and then you will list, in this case, we have 64 and PC. 64 is going to be the environment type that needs to be injected, and PC is indicating the PC software encryption. If you were to be building for an Opaltech, then you would have noted Opal instead of PC. And then, of course, if you're building for 32-bit, you would have listed 32-bit rather than 64-bit for the environment type. At this point, the script is carrying out the majority of functions that are listed in the DETech guide and building the WinPE environment. And upon completion, you'll see this message indicating that it's done, and to create an ISO or a bootable CD DVD, you'll need to follow the remaining instructions from the guide. There is a command in the guide here. This is an exact copy and paste that has the syntax of what's necessary to produce an ISO file. As noted before, if you use any difference in directory in your prior commands, they'll have to be compensated throughout. So we'll adjust because we use a slightly different path. once that's done, we can execute the command and it will render an ISO file for us. And as it's completed, we should have our ISO file. It will list the directory in which it was saved. And this ISO file can either be used to burn to optical media, CD or DVD, or it can be utilized with any third-party tool to place the ISO onto a USB to make bootable USB media from it. Going to the subject of the EZPE, this is not an officially supported tool. It's offered as a free tool and as is. The full end user license agreement information is available at the following location. Within the EZPE tool, this gives a GUI-based option to create the WinPE environment. You'll notice at the top, it does give you the ability through this tool to download and install the Microsoft ADK. That has to be present to create a WinPE environment, as it's the source of the WinPE environment itself before DETech is even injected. After you've been through that process of installing the ADK, either through here or manually, you can then select the DETech or DE Opeltech recovery media that you wish to build and have it render an option for you. We've got a small sample video. We also have, there's additional customization options like using your own background image within the PE environment. You can choose a 1024 by 768 option or just use the default. And upon completion, it provides an ISO file when booted to the WinPE environments that are created by EZPE. They will have a bit of a customized appearance by comparison to the base WinPE environments. You'll have a menu, including one with the McAfee tools within, also listing for that ETech code generator. We'll be able to launch the ETech application. You'll notice there is no emergency boot option, as this is a WinPE environment. We can still authorize with the code of the day and authenticate using the token or file option, just as we would in a standalone. But different than the standalone, in this environment, we now have the ability to utilize a file browser. The EZPE includes a file browser, but you're also free to use one of your own. On an encrypted disk, we can still go in after authorizing and authenticating. We can go in and view the contents of the disk, locate any applicable data that we find of any importance, and this can be copied off to external media, allowing you the ability to back up anything and or everything that you need to, and then carry out any further actions safely without any risk of loss of that data. That can be either a decryption through MDE, that could be a forced decryption if it was necessary. Some may even choose to re-image the system and then return the data, depending upon their interests in installed applications and the speed of your imaging process. We also have a free tool out there called EZDE. This is also not an official tool, and it's not a recovery tool, but it is part of the EZ tool suite. It provides access to MDE related information within the Windows environment. To launch and run it as administrator, this application will give you a GUI window with numerous information points for drive encryption. Lists information on the installed components, including DE-Go, whether the software is installed, the health state, as well as the DE components themselves, their version, their log level, and whether the system is using Opal. The currently logged in drive encryption is used or listed there. We also have information on the drive states, whether PBA is active. You can view information on the current theme that's shown in the preboot file system itself. And then we have the ability to get information on the McAfee agent 5.x and later as well. You can launch the McAfee agent status monitor from the EZDE tool. And you also have the ability to validate drive encryption users. We're going to show an example here of validating the presence of a user. This one we do know to be assigned, but this gives an example of validation for one that is. And that user is indicated as assigned. We now return to the menu and we'll enter a username for one that is not assigned to show the opposite instance. In this case, we know that this user was not assigned. So this is a good option to confirm or deny the assignment of a user. You also have the ability to view the drive encryption log, the MFE EPE log within this GUI. There's information on the drive encryption best practices, FAQs, the ability to contact the author of the EZDE tool, access to the service portal, grant portal, and McAfee Security Services. Leaving the recovery disks behind in the subject of an EPO disaster recovery scenario can come up from time to time. KB Article 66616 is the backup and disaster recovery article for EPO. When considering it with drive encryption, as well as other point products, there are potential issues. For drive encryption, new systems that have been activated and encrypted since the backup was taken can be a problem if you're restoring to that backup. All of those systems since that time will not exist in that backup. Any systems that were just added to the EPO environment since then would not be included. Any changes since that time, like the addition of users or policy changes, would be reverted whenever you restore to the backup. To address these issues, we can identify any missing systems after the restore. You can temporarily apply an automatic booting policy to prevent the impacts that can come up from the user situations, because a machine object that was added after the last backup that will no longer be in EPO when you restore to that backup would potentially lose its users. This prevents the impact until you're able to use that add local domain user functionality or manually assign users to the system. The drive encryption software is designed to re-upload its recovery data in any instance where it detects a change in its machine ID or EPO server ID. So if it's going back to a recovery of the same EPO server, while it won't detect a difference in that server ID, it will get a new machine ID. You can also use the system transfer option if your original EPO server cannot be recovered. If you don't have that recovery, that backup data, or if for some reason you're not able to re-implement it, you can set up a new EPO server and direct your drive encryption clients to it. The guide for the drive encryption client transfer is PD 27693. The summary or key takeaways of that document will indicate first that the destination server, or new server in this case, must be a mirror of the original. This is making sure that all of the configuration, the policies, the registered LDAP servers are all set up the same as they were before. The same thing will apply for other point products, making sure the policies are as you want them to be before getting the clients moved over there. The system transfer functionality for drive encryption needs to be enabled either through API or through scripting. There is an example Python script included with the drive encryption scripting examples that does enable the transfer functionality. And once this is done and the systems are provided the new McAfee agent to talk to this new server, the recovery keys will be uploaded and the user assignments and their token data will be transferred to this new EPO server.
And this concludes today's webinar.